So you're swimming in data, and you're trying to figure out what's real and what's just random noise. How do you do it? Well, today, we're going to talk about a fantastic statistical tool called Way ANOVA. It's basically your go-to method for when you're comparing not just two, but a whole bunch of groups at once, and you need to know if any of them are genuinely different.
And to really get in the right headspace for this, I love this quote from our source material. It kind of frames the whole field of statistics as this art of looking at a chaotic world and finding the pattern, the real signal that matters. And that is exactly what ANOVA helps us do. So, to get to the heart of it, I want you to think of this session as our own little data salon. Yeah! This isn't about getting bogged down in formulas or complicated math. Nope. We're here to talk about the big, elegant ideas behind the numbers, the concepts that really help us make sense of the world.
Okay, so what is the big problem we're trying to crack here? Well, imagine you're a marketer. You've moved way past just testing ad A versus ad B. You've got A, B, C, and D. Or maybe you're a scientist with 4 potential new treatments. How in the world do you figure out if any of them are actually making a difference? Your standard A-B test just won't cut it.
Let's make this super clear with an example from our source. Picture this. We've got 60 people, and we randomly assign each of them to one of 4 different diet plans. After 6 weeks, we check in. And right here, you can see that the 15 people on diet A lost, on average, 9.18 pounds. And of course, the other groups will have their own results too.
So you look at the results, and the average for each diet is going to be a little different, right? Of course they are. But here's the million-dollar question. Is that difference real, or is it just random luck? Is it possible we'd get these numbers even if all the diets were, in reality, exactly the same?
And that is where Way ANOVA struts onto the stage. ANOVA stands for Analysis of Variance, and it is the perfect tool for this job. It's designed to look at the differences between all these group averages and tell us if we're seeing a genuine effect or if it's all just statistical noise.
So how does ANOVA actually approach this? Well, like a lot of statistical tests, it starts out as a total skeptic. It doesn't try to prove something is true, it actually tries to prove that the opposite is wrong. That is, it tries to see if it can reject the idea that absolutely nothing interesting is going on. It does this by setting up this little head-to-head battle. On one side, you have what's called the null hypothesis. Think of this as the boring hypothesis. It's our starting assumption. All the diets are the same, no difference at all. On the other side, you have the alternative hypothesis. This is the exciting one. It says, nope, at least one of these diets is not like the others. The whole point of the test is to see if we have enough evidence to throw out that boring null hypothesis.
Now, if there is one analogy you remember today, make it this one. The absolute best way to think about ANOVA is to see it as a screening test. It's not the final, detailed diagnosis. It's that first quick check that tells you if something warrants a closer look.
So what does this screening test actually tell you? It's really simple. It gives you a yes or a no. A yes means, hey, we found something. There's a statistically significant difference in here somewhere. A no means, sorry, not enough evidence to say anything is different. But, and this is so important, if you get a yes, ANOVA does not tell you which diet is the winner. Is A better than C? Is D the worst? You don't know yet. All it does is wave a big flag and say, dig deeper right here.
Okay, but before we can trust the results of our screening test, we have to make sure the game is fair. There are a few rules we need to follow. And these aren't just boring technical details. They are the bedrock that makes our final conclusion actually mean something.
Here's the quick checklist. First, your groups have to be independent. The people in diet A can't be influencing the people in diet B. Second, you need a random sample. Third, the data spread, or what we call variance, needs to be roughly the same in each group. And finally, your data in each group should look something like a bell curve. Or you just need to have a pretty big sample. Usually more than 20 people per group does the trick.
So you might be thinking, that's great, but what happens when my real-world data is messy and doesn't follow all those rules, right? Maybe my samples are small as the numbers are all skewed to one side. Do I just throw in the towel? No way. Statistics has a plan B.
And here is that plan B. If the standard ANOVA test isn't right for your data, you can use something called a non-parametric alternative. The most common one is the Kruskal Wallis test. And what it does is pretty clever. Instead of looking at the actual pounds lost, it just ranks everybody from the person who lost the least to the person who lost the most. And then it compares the average rank of each diet group. It's a really solid way to ask the same basic question when your data's a little wild.
Okay, so we get the idea behind the test.
Now let's bring it all home. What are the big picture concepts you should really walk away with to use in business, marketing, or your own research? I think it boils down to 3 really important takeaways.
Takeaway number 1. Remember what ANOVA stands for: analysis of variance. At its core, it's just comparing 2 things. It looks at the variation between the different groups and compares it to the variation within each group. If the signal between the groups is way louder than the random noise inside the groups, then congratulations, you've probably found something real.
And the implication for business is massive. Think about it. You can use this to test 3, 4, even 5 different versions of a website to see if one gets you significantly more sales. Or test a bunch of ad campaigns to find the one that truly generates more clicks. It's the perfect tool for picking the real winner out of a crowd.
Okay, takeaway number 2, and this is the big one. Always remember that ANOVA is your screening tool. I'm going to say it again. It's your first pass. It is not your final answer. Its entire job is to tell you if there's a signal even worth looking for.
So, what does that mean in the real world? Let's say you test 3 new store layouts, and your ANOVA test comes back significant. It finds a difference in customer satisfaction. That's your green light. It tells you, yes, one of these layouts is better. Your very next step is to run more focus tests to pinpoint exactly which layout is the champion and which ones are lagging behind.
And our third and final takeaway today is simple but absolutely critical. The rules matter. Those assumptions we went over, they're not just for academics. The quality of the business decision you're about to make depends completely on the quality of your test.
The bottom line is this: making sure your test is set up correctly is non-negotiable. If their groups aren't really random, or if they're influencing each other, then your ANOVA results is basically worthless. It's that old saying, garbage in, garbage out. A flawed test can trick you into pouring money down the drain on the wrong strategy. So good experimental design is just smart business.
So, there you have it. Way ANOVA in a nutshell. It's this incredibly useful screening tool for finding the signal in the noise whenever you're comparing multiple groups. And that just leaves us with one final thought to chew on. In the data you look at every day, what crucial differences, what winning strategies might be hiding in plain sight, just waiting for the right test to bring them into the light? Thanks for stopping by the Data Salon today.